Hello and welcome back to another video. In this problem, we have the equation of a circle. We're looking to find its radius. So this is not the standard equation of a circle. That would look like x minus h squared plus y minus k squared is equal to r squared, where the center is hk and the radius is r. So how do we get this into this form? Well, we have to complete the square. So we have x squared minus 5x plus some constant is going to give us this. Y squared minus 3y plus some constant is going to give us this. And if we add the constants that we added over here to this side, both sides are going to stay equal. And then whatever this value is over here, that's going to be equal to r squared, which is going to allow us to find r. So over on this side, we have x squared minus 5x plus whatever that constant is. Over here, we have y squared minus 3y plus whatever constant this is. And that's going to be equal to 33 over 2 plus those same two constants. Again, we want to add them on both sides to keep it equal. So how do we find this? Well, the trick to do is if the coefficient on the squared term is 1, all you have to do is divide this term by 2. So we have negative 5 divided by 2, and then square it. Same thing here. The coefficient is 1, so we don't have to worry about that. So we just take the middle term, negative 3 divided by 2, and then square it. Again, we're adding them on both sides, so this, we're going to add negative 5 halves squared and negative 3 halves squared. Now, you could go through and try and get it into this form of the x minus h bunched together squared, y minus k bunched together squared, but realistically, we don't have to worry about this side of the equation. We're looking to find the radius. We only have to find out what this value is. So if we separate this off, what is that going to turn to be? So just rewriting it here, we have 33 over 2 plus negative 5 over 2 squared plus negative 3 over 2 squared. Alright, so now if we square these out, you just have to square the numerator divided by the square of the denominator. So we have 33 over 2 staying the same, plus negative 5 squared is 25, divided by 2 squared is 4, plus negative 3 squared is 9, divided by 2 squared is again 4. If we add these two together, while they have a common denominator, we get 25 plus 9 is 34. Again, denominators are the same. If we want to get the denominator same for these two, if we divide the top and the bottom by 2, we're essentially dividing by 1 since 2 over 2 is equal to 1. So 33 over 2 is staying the same. 34 divided by 2 is 17. 4 divided by 2 is 2. And now these have a common denominator, so we can add numerators and keep the denominator the same. So we have 33 divided by 7, it's going to be 50, divided by 2 with that common denominator, and 50 divided by 2 is equal to 25. So what does that mean for this problem? That means that 25 is, again, this value on this side is equal to r squared. So if 25 is equal to r squared, we can subtract 25 from both sides. 0 is equal to r squared minus 25. Difference of two squares. Do this. You can just take the square root of both sides, but I find it hard to remember that you have to take the plus or minus of the square root of 25. I just think it's easier to factor it out. In this thing, we're going to have r plus 5 is equal to 0, and r minus 5 is equal to 0. One of these has to be 0 for this product to be equal to 0. And just solving for r in these two situations, we have r is equal to negative 5, or over here, r is equal to 5. So r is representing the radius of a circle. It has to be positive, so it can't be negative 5. r has to be equal to 5. R represents the radius. We're looking for r. This is going to be our answer 5. As always, thank you for liking and subscribing, and I'll see you in the next video.